this example, we're relating the height of a tree to its age. So the age is an independent variable. The height of the tree is the dependent variable. So the relationship to this function, there's our equation here. So we're going to write this as in function notation. So I'm going to say f of x is equal to, so our input is age. So we multiply the age by 15 and add 100. So at age 0, if I plug in 0, it's 100 centimeters high. And at age 1 year, it's 115. 4 times 15 plus 100 is 160. So it looks like for every year, we're adding on 15. Okay, so 10 years, we're going to add on 10 times 15. So 150 becomes 250. So this is 325 when I do 15 times 15 plus 100. And 20 times 15 is 300 plus 100 is 400 centimeters. Okay, so there's our table of values. What are our x and y intercepts? Well, our y-intercept is the initial height. Okay, so that's our y-intercept when x is 0. Y-intercept is when x is 0. What's the x-intercept? Well, to get an x-intercept, we kind of have to go backwards in time. Okay, so if I graph this like this, I have 100 centimeters here, and it's kind of growing like that, and I'd have to go backwards in time. That's negative time. It really doesn't exist. Okay, so that x-intercept is not relevant. Unless you can somehow go backwards in time in this problem, which I don't think we really should assume. It's not relevant to this problem. Okay, so this is what it looks like so far. I can plot some of these points on here. So let's say that that's 100. So we're going to say that that's about 20 years. So let's make their x-axis maybe negative 10 to 20. The y is going to be looks like maybe negative 200 to positive 400. Now this isn't the greatest window. I just drew this window to kind of illustrate this going backwards, but that's good enough. Again, our windows don't have to be perfect, they just have to be good enough, and this is not a good window, but it's good enough. Okay, and I can just kind of put my points in there. They're going to end up along that line. I can assume that this is a linear function because of the multiplier on here like this. So it's asking, what is the ratio of change in this relationship? Remember, the ratio of change again shows up on the outside. So I can just see how it changes. So we'll compare the change of y to the change in x. That's going to show up on the outside of the function. It's plus 45 centimeters for 3 years. And if I simplify it, it's plus 15 centimeters per year. And again, we want to relate that plus 15 centimeters per year as the multiplier, and it will show up as slope. Okay, so in this case here, it might be like plus 3 plus 45, and shows up as the slope ratio. So how old is a tree when the height is 200 centimeters tall? Well, looking at this, it's somewhere between 4 and 10 years, because 200 is somewhere in there. How do I go about finding this? Well, in this case, I'm not going to plug in x, because I don't know the age. I'm trying to find age. I know the height. So if the tree is 200 centimeters, 205 centimeters, I can say the height equals 205. And that's equal to 15 times the age plus 100. And then I can undo this calculation or solve. So subtract 100 from both sides. So I knew it grew 105 centimeters in 15 years. So if I want to know the age, I need to get rid of the 15 centimeters per year. So I need to undo the times. 105 divided by 15 gives us 7 years. Okay, so the age of the tree then must be 7 years to get up to 205 centimeters.